Hey, hi everyone. Today we are going to solve one of the fascinating problem, and this is really crucial regarding the interview process also. Okay. The question name is merge two sorted list into the one of the list. So what they are saying, you are given heads of a two linked list one, list two, and merge those two lists into one sorted list. So the question is pretty straightforward, and we have to do that. So suppose this is 1, 2, 4, this is 1, 3, 4. These are the two lists, and we have to merge into the sorted order. We have to maintain the order into the ascending order. Okay. So basically, this is a pretty simple problem and can have three approaches to solve this. First is a brute force approach, which anyone can solve. There is a better approach using recursion. We can solve this problem easily, but there is a still extra space used for recursion uh, in terms of a implicit stack. And third is a two pointer with iterative approach. So there will be we will be using a no extra space. Okay. So let me note down the approaches for you. So the brute force, uh, the time complexity and space complexity. The brute force time complexity will be O of n plus m, right? N is a okay, and space complexity also n plus m. So that is the time and space complexity. We will come to that. We will go through each solution one by one and we will discuss the time and space complexity promptly after solving this problem with a particular approach. So for using recursion, like recursion, better. Okay. So recursion will be having a time complexity of n plus m only, but the space complexity will be uh, max of n plus m, max of n comma m. We will get to that how it will be maximum for n comma m. Okay. And third is a iterative two pointer best. So the time complexity will be n plus m because time complexity will be same. To create a new linked list with the sorted order, we have to visit each element into both the list, and count of all the elements into the two linked list will be n plus m. So the time complexity can't be reduced. Okay, and space complexity will be O. Okay. So let's discuss about the brute force approach. So we have one list, we have second list, and what we can do is we can put one pointer on the list one, put a second pointer on the list two, and we can just compare. If pointer one has a less value than pointer two, then create a new node and assign it. Create a new node and assign it to the new list. So in this case, let's say into this diagram. So the pointer one will be on the one, pointer 2 will be on the P2. 1 are same, so we can take any order. So suppose we took this one. So P1 will go to the 2 and again we will compare P2 and P1. Now the P2 value is less than the P1. In this case, we will create a new node for this one and we will add it. And P2 will go on the 3. So P1 is having a 2, P2 is having a 3. In this case, P1 value is less than the P2. So we will create a new node for P1 and we will add that. And P1 will go to the 4. So same. P1 is having 4, P2 is having 3. In this case, P2 value is less than the P1. So we will create a new node for P2 and we will add it. So the P2 will also go on 4 and same so on. So let's try to code this. So this is a pretty straightforward problem, very easy. Anyone can solve this. Anyone in the interview can start with this solution. Okay, so there will be a better impact and it will be a time consuming also. It will take at least 10 to 15 minutes in your 1 hour interview. Okay, so the brute force is a okay. Let's take a P1 pointer on list one and a P2 pointer on list two. Okay, so we took two pointers. So to create a new list, create a one dummy node, uh, dummy head, I would say, dummy head list node, and assign the current pointer to the dummy head. This is a new head, like list head of a new list. Now take a loop until both the pointers are not null. Okay, while P1 and P2. Now check, as we have discussed, if a P1 is less than the P2 value. If P1 is less than the P1 val is less than P2 val. In this case, create a new node, list node of a P1 dot value, whichever is the lesser, and assign that new node to the new list. So new list will be current dot next equal to new node, and move the P1 pointer ahead into the right direction. P1 equal to P1 dot next, and vice versa. Okay, create a new node uh, for the list node of a P2 value when P2 value is less than the P1. Assign it to the new list current dot next equal to new node. Move the P2 pointer if a P2 value is less than the P1. Yeah, as you can see, this is a pretty simple and straightforward. And at last, whenever we are creating a new node, right, and assigning it to the new list, we have to move the current pointer ahead into the right direction. So current equal to current dot next. And at last, we have the dummy head, and which is our next node of a dummy head, right? That will be the head of a new node, new list. So as you can see, it will visit each node once. So time complexity will be O of n plus m, and space complexity is we are creating altogether new list for this. So the space complexity will be O of n plus m. Let's try to run this. So there is one issue. Let's check. Yeah. So suppose matlab, one list, matlab we have reached the end of a one list and still there is a one list remaining. In this case, we want to assign that altogether new list to the uh, like a new list. Suppose I will take example. So 1 comma 2 comma 3, 1 comma 4 comma 5 comma 8. Okay, and suppose this list is a 2. So in this case, we will reach end of the list 2 very early in the phase of coding, right? So we will reach the end and our P1 will be on the 4. In this case, what we want to do, whatever is the remaining part is, right? We want to add all together into the new list. So we have to do that. So current dot next equal to if assign P1 if it is not null, else P2. That's all. So this is a pretty straightforward and it should run fine. Okay, let's submit this. Yeah, it is working fine. Cool. So this is a brute force approach. Let's try to understand the recursive solution and we will try to code this. And after that, we will try to understand the two pointer approach, iterative approach, and on the top of that, we will code that also. And we will understand time and space complexity also. So let's get to the pen and paper for the recursive solution. Hey, let's start with the base cases. Like how can we solve this problem using the recursion? So suppose L1 is null and L2 is null. In this case, what we will do? Do you get any idea? So in this case, what we will do, like if both are null, then return null. So that is the first base case. This is second base case. So suppose L1 is a null and L2 has a one node or two nodes or n nodes, something like that. In this case, if L1 is null, return L2. So you can see after merging the list, we will get a 1 2 जो भी है L2 वाला list. So third base case is L1. L1 is some list of N nodes and L2 और है यहाँ पर. So this is or कुछ भी हो सकता है and L2 is null. So in this case, if L1 null नहीं है लेकिन L2 null है, then return L1. So these are the base cases we need to handle. So this is clear, right? Let's take one example. So suppose this is a L1, 1, 3, and it will be null. So this is L2. So this is not a base case. So we will have on one node. So suppose our P1 pointer will be here, P2 pointer will be here. So at a high level, we are having these two pointers and we are passing this to the recursive function. So function name is merge P1 comma P2 and it will return the head of a new list, merged list. Okay. So in this case, we will pass P1 and P2 and we will check if any one of them is a null, then return the other. And eventually, if a P1 is less than the P2, right? So what we will do, we will call the recursive function for the next node of P1 and the P2. So like this. And whatever will be the output of a P1 as a 3 and P2 as a 2 will be added to the next node of a P1. Take care. So now you can see P2 is less than the P1, right? So in this case, we will call the recursive function for the P1 and the next node of a P2. And what will be the whatever will be the output, right, will be added to the two. So suppose uh, let's write this diagram once again. L1, L2. So this is 1, this is 3, this is null, and this is 2. So this is a P1, this is a P2. So P1 is less than the P2, right? So in this case, we will move ahead the P1 and we will call the recursive function for P1 and P2 again, right? So P2, let's write down the null here. So P2 is less than the P1, right? So we will move the P2 ahead and we will call the recursive function for P1 and P2. So this is a base case. One of the pointer is null, right? So in this case, our function will return this node with the value 3, which will be added to the previous node. Okay. And so whatever the function with the P2 and P1, right? It will return the value as a 2. So it will be added to this node. So this link is cut, this link is cut. The new list will be 1 comma 2 comma 3. Now let's try to understand with the call stack. Okay. So L1, ये रहा 1, this is 3, this is null, this is L2, this is 2. So this is a call stack. So first function is 1 comma 2. So 1 is less than 2, then we will call 3 comma 2. So 2 is less than 3, so we will call 3 comma null. So in this case, it will return 3. So in this case, it will return 3. So as you can see, it will return 3 for the function 3 and 2. So we will attach this. Okay. And this link is discarded. And among 3 and 2, it will return 2. So this link will be discarded and 1 is attached to this. So you can see the new sorted list is created. So that's how we can solve this problem using recursion. And the pseudocode. So this is a function p1 comma p2,
and this is a new head. So if p1 is null, return p2. If p2 is null, return p1. These are the base cases. And at last, if p1 matlab both are not null, value is less than the p2 value, then call the function for p1 dot next जो भी next है and p2, and attach this to the p1 dot next. Else else call this function again अगर p2 value is less than the p1 comma p2 dot next, and attach this value to the p2 dot value. That's all. So the time complexity of this solution will be O of n plus m, because we have to visit each node once, and space complexity will be O of n plus m. So that can be no O of n plus m nahi, maximum of a maximum length of any linked list, because in worst case it will go into this is m, it will go into the suppose the one list is having 100 nodes, right, and second list is having 99 nodes. So in the worst case call stack will contain only 100 function into the call stack, like list of 100 functions. So because the space complexity will be n comma m, and this is slightly reduced from the previous brute force approach. So let's try to code this.
Okay, let's try to code the recursive solution. So what we have shown is like if list 1 is null, then return the list 2. If list 2 is null, then return the list 1. And if value of a list 1 node is less than the list 2 node, in this case, we will recur for next node of a list 1 and the list 2 node, something like that. So suppose this one is less than or equal to the list 2 node. So in this case, we will recur for this 2 and this one, like this, and whatever is the output we will connect for the list one node. So let's try to code this. If list 1 is none, then return list 2. If list 2 is none, then return list 1. If list 1 dot value is less than or equal to list 2 of value, in this case for list 1 dot next we will recur for remaining nodes of a list 1 and all the nodes of a list 2. So self calling the function recursively. So pass the next node of a list 1 because we found the smallest node between the two. So now recur for the next node. So list 1 dot next and list 2, and at last return the list 1. Else in this case list 2 node is less than the list 1 node. In this case for list 2 dot next, call the recursive function merge to list and pass the list 1 node as it is, because it is greater than the list 1 node, and pass the next of list 2 node. So in this case, like for example, suppose this is a 1, this is 2. List 1 is a 2, list 2 is a 1. In this case, list 2 is less than the list 1. So we will recur for 2 to 4 and 3 to 4. In this case, list 2 dot next and return the list 2. So let's try to run this. Yeah, it is working fine. So the time and space complexity, let's try to analyze that. So basically, as we have discussed again, time complexity will be O of n plus m, and space complexity will be like whatever is the maximum length of any list light that will come into the stack. So O max of n comma n. So that is a time and space complexity for this solution. This is a pretty straightforward problem and pretty simple problem. So that is the better solution. Now get on the let's get on the pen and paper and try to understand using two pointer and without extra space how can we solve this problem. Okay, that will be gonna really interesting. Let's jump on.
We have seen the brute force approach for merging the tool list, and we have also gone through the recursive approach where we can reduce the space complexity by bit. So in the third approach, we will see if we can merge the two sorted list into the single list without using the extra space. Can we do that? Yes. Why can't we do that? Let's take the examples. So this is example. So suppose this is 1, this is 3, and this is 7. That is a list 1. Okay. So this is a list 2, this is 4, and this is 5. So, can you tell me what will be the answer list? 1, 3, 4, 5, and 7. That will be the answer list, right? So, in this case, what we have to do, we have to connect this part to the 4 and ye wala part to the 7. So, the flow will go like 1, 3, 4, 5, 7. Like, how can we do that? Is it that simple? Yes, we can use only two pointers, that is sufficient enough. So suppose this is 1, this is 3, and this is 7, and this is 4, and this is 5. So what we will do, we will keep one pointer known as a smallest, which is having the small value, and one with the largest vessel, which is having the large value than the value of the smallest pointer. So in this case, we will move the smallest pointer until it has the greater value than the largest, or it will be the null. So in this case, small will go to the 3, small will go to the 7, small will come here. Okay. And what we have to do, जो भी element is a previous of smallest light, so we should connect to the largest element. Okay. In this case, now you can see the list, ये link will be discarded. Okay. The now linked list will be 1, 3, 4, 5. That is clear, right? Okay. In this case, you can see the value of smallest is 7 and largest is 4. In this case, we want to switch the pointers. So we will keep the largest here and smallest here. Now the same procedure. Move the smallest ahead until it will be the null or having the lesser element than the largest. In this case, the smallest will go to the 5 and smallest will go to the null. This will be the null, right? So you can see whatever is the previous element of a smallest, right, which is 5, we want to connect it to the largest element. Okay. So now you can see this link will be discarded. 1, 3, 4, 5, 7. That's all. Again, our we will come to the outer loop, and you can see one of the node is a like a null, right? Smallest is reached the null. So in this case, we will stop. Is that clear? Let's write the pseudocode. So uh, take a loop until both are not null. Both means smallest and largest pointer. Okay. Now uh, let's have a previous pointer just to track the previous node of a smallest pointer. Okay. Just to add the particular node. In this case, take a loop until while smallest and value of smallest value is less than equal to largest value. In this case, move smallest ahead and cache the previous pointer. Caching the previous pointer means whenever we are moving the smallest ahead, right? First of all, uh, keep the previous pointer on the smallest, then move the smallest ahead. So it will just follow the smallest pointer. After that, if we reached the terminating condition, like smallest is null or smallest is having the greater value on the largest node, so in this case what we will do, whatever will be the previous node, right? Previous, okay, next may we will add the largest, so the link will be broken. So suppose this is a 137, right? So in this case, let me take one example. So 137, right? And this is 4 and this is 5. So our previous will be here and smallest will be here. So in this case, we will add the previous to the largest and switch the pointers. Switch the pointers. And in this case, smallest will come here, largest will come here. Okay. So that is a pretty straightforward algorithm, and time complexity will be O of n plus, we are visiting each node only once, right? N plus m. And space complexity will be, we are using only two variables, three variables, right? So that is O of 3, which is O of 1. The space complexity is constant, and this is a one of the best solution to solve this problem. Okay, let's try to code this.
Cool. Let's try to code the problem using iterative solution. So first of all, we will check if any of them, if list 1 is none, then return list 2. If list 2 is none, then return list 1. And so take a smallest pointer at list 1 and the largest pointer on list 2. And if smallest dot value is greater than largest dot value, then just swap the nodes, smallest comma largest. So this is the way how we can swap the values and nodes into the Python. Smallest, ठीक है. So for example, यहाँ पर वो 4 है and यहाँ पर 1 है, ठीक है. In this case, smallest will be on 4 and largest will be on 1. So in this case, just swap the nodes, ठीक है. And take a new head and assign it to the smallest, because that will be always the first node of a merged sorted list. And then call the merge function, pass the smallest and the largest to the function, and return the new head. Now let's write the merge function. Okay, merge smallest comma largest. Take a previous pointer, assign it to the none, and while smallest and largest, if both are not none. So while smallest, if a smallest is not none and value of the smallest is less than or equal to largest, then assign मतलब cache the smallest node into the previous. So we just have to follow the smallest node using previous pointer, smallest, and the smallest ahead. Okay. And then assign the previous next to the largest and swap the nodes we have seen into the algorithm. Yeah, that's all. uh, Let me check the names. Smallest, smallest, smallest. ठीक है, largest. Let's try to run this. I'm not sure whether there is a typo or not. Yeah, all the cases are passed. Let's try to submit this. Yeah, it is working fine. So the time complexity, as we discussed yesterday only. So we are visiting each node of both the list. So the time complexity will be linear, and on the top of that, we are just using a two variables, smallest and largest, even though that is also not necessary. So the space complexity will be O of 1, which is constant space, and that is a best solution using which we can solve this problem. Okay, so whenever you are encountering this question, you can start with a brute force. You can come with a better, and you can at last solve with this best approach with a constant space. ठीक है, चलो